Welcome to Gazang's video training, where today we will learn how to set up an Amazon EC2 server, install ezNcrypt on it, create a process-based ACL rule, encrypt a MySQL database, and test it. ezNcrypt is a transparent data encryption solution for any data used by virtually any application running on Linux. Our customers encrypt their sensitive data like PCI, HIPAA, intellectual property, and more. And all this happens without making any changes to those applications or the data. Let's go set up our Amazon EC2 server now. First, log into the AWS Management Console and launch a new Amazon EC2 server instance. Select an appropriate AMI that meets the needs of your project. Don't forget to take ezNcrypt system requirements into account. ezNcrypt requires a Linux kernel of 2.6.19 or newer. Or if you're using Red Hat or CentOS, then you'll need a kernel version of 2.6.18-192 or newer. As a side note, these kernel version requirements for ezNcrypt are driven by the need for eCryptFS, the embedded encryption module that comes with the Linux distribution ezNcrypt supports. Finish up the advanced image configurations like key pair and selecting or creating your security group. Finally, get ready to launch your new server instance by checking over the configuration summary. If everything is correct, click Launch. You'll see a confirmation that your instance is launching, and soon after you'll be able to access your server. Now we're ready to run through the installation of ezNcrypt. To download ezNcrypt, you first need a product key and activation code. The fastest way to obtain these is by going to www.gazang.com and clicking on the green Try Now or Try ezNcrypt for free links. Complete the form, and almost immediately you'll receive an email with download instructions. Here we're using the FTP site to obtain the current release of ezNcrypt. Once you have the appropriate file for your system architecture, either 32-bit or 64-bit, run tar xf to expand the file. What you'll end up with is a README, our install shell script, an ezNcrypt installer, and an ezNcrypt config tool. You are able to run the ezNcrypt installer first and then configure it with the config tool independently of each other. Or run the install shell script and it will attempt to do the install and the configuration in one step. Running the install wizard will present the license agreement. Scroll through the entire agreement, then to continue, click Yes to accept it. The default installation directory is opt ezNcrypt, but you can specify the directory you'd like depending on your requirements. The install wizard will check for underlying dependencies and see if they're installed. You can stop the install wizard and take care of any missing components manually, or let the wizard take care of it automatically for you. Select the encryption cipher you want to use. We recommend AES-256, the default option, but you can configure ezNcrypt to use any of the options you see listed here. Next, select your KSS connection settings. Now it's time to enter your product key and activation code. These were in that email you received after requesting a trial or purchasing ezNcrypt. When that's done, set your passphrase and optional salt. We designed this to provide very strong security by having dual authentication for when manual decryption is necessary. With one person knowing the passphrase and another knowing the salt, no single person would be able to decrypt the information protected by ezNcrypt. Please refer to the user guide for how to set up an RSA key file as your master key. This is important. Please record your passphrase and optional salt and keep them in a safe, secure location so you'll always be able to decrypt your data. Once the installation is complete, it's time to run the ezNcrypt config tool, which helps to create trusted applications using ezNcrypt's process-based ACL rules. At the time this video was made, the ezNcrypt config tool was able to help create ACL rules for MySQL, Apache, and Postgres. Remember, it is possible to create other ACL rules for virtually any application running on Linux. You are not in any way limited to the applications covered by this config tool. Here we'll focus on creating the process-based ACL rules for MySQL. If your installer did not pull up the config tool automatically, go ahead and run the ezNcrypt config tool script as seen here. You can choose which components you want to configure. but we will just select MySQL and, for now, skip Apache and Postgres by selecting No for each of them. When asked what type of credentials you want to use, you'll need to choose the same credential type, either passphrase or RSA key file, that you set up during the initial install of ezNcrypt. Now you're ready to set the specific configuration for your installation of MySQL. The config tool will check the typical locations and configurations and present those back as the default input settings for your server. It will look for your MySQL start command, the stop command, the path to MySQL admin, and it identifies your MySQL executable and the data directory. Once these parameters have been identified, it's time to create the actual process-based ACL rule. These rules are relatively simple, a little bit like a firewall rule. Set the type of rule, allow or deny. The category, this is actually a name or a label for your rule, and it's used to link the rule to the data that you will encrypt later on. Path, this sets a boundary of what directories the rule can be applied to. Most of the time you'll just use an asterisk wildcard so that the rule could be applied to any directory on your system. And finally, the exact file and its full path that runs your trusted process. Select Yes or No to set up a log encryption rule, and it will configure your ACL rules for you. Please see the user guide for more information on the process-based ACL rules and their settings. To finish up, let's encrypt a MySQL database called employees and see what happens to the data once it's protected with ezNcrypt. Before we do that, let's open up one of the tables in our database using a text editor. I've navigated to var lib mysql employees, and then using VI, opened up the table called titles. As you can see, the contents of this table contains various titles of our employees in plain text, such as engineer, staff, senior engineer, etc. To encrypt the database, we use a special command that ezNcrypt has for encrypting MySQL databases, and it's called ezNcrypt-mysql. This command automatically stops the MySQL process before encrypting the files and then restarts it upon completion. We encrypt the employees database, and ezNcrypt asks for MySQL root credentials. It contacts the KSS to retrieve the master encryption key, stops the MySQL process, and then encrypts the database. What happens now is the files are relocated to var lib ezNcrypt directory, and the data is encrypted as it's written to this new location. Once this is done, if you go back and list the contents of var lib mysql, the original data location, there is a symbolic link now pointing to the new location of the data, var lib ezNcrypt. If we follow the link and try to list the files of the employees database, we get a permission denied message. This is part of the security that ezNcrypt provides. What's really going on is the encrypted files are physically located in a hidden directory called var lib ezNcrypt.encrypted_private. Now when we try to open the titles table from this location with our text editor like we did before, you will see that the data is garbled and useless to anyone trying to exploit the sensitive information we've stored there. That covers the basic procedure for how to set up an Amazon EC2 server, install ezNcrypt on it, create a process-based ACL rule, encrypt the MySQL database, and then test it. We will be adding other installments of Gazang's video training in the near future. If you would like more information, please contact Gazang.